Take two.
Okay, where the fuck, where are we at? So, been having some wild times with codecs. So, today it did a 42-minute run and it
Mm-hmm.
blew its
42 minutes.
context. Yeah, 42-minute, and it blew its
Oh,
context window.
oh.
Um, it was ultimately unsuccessful at the task it was attempting, but by golly, did it try. Like, I was watching it and it was
What
working.
was the task? What were you trying to get it to do? That takes 42
I
minutes.
I've started giving it the job of deploying straight to the infrastructure and then probing the infrastructure to test that it worked okay, including programmatically browsing to the deployed infrastructure sites, checking the logs, and then making fixes and then redeploying.
Well, that sounds quite a lot.
Those are heavy tasks.
Yeah.
Those are the tasks that I do normally.
Yeah.
And you mess around and you try and be clever and have unit tests and things so that you, when you deploy, you get it right. But then I'm like, the bot first of all does the unit tests. The bot does the integration test, the deployment, and the bot sort of knows better or just sits there looping through fixing it, inserting little logging lines and test lines and things in the code, redeploying, theorizing, web searching. I almost don't care if it gets it wrong sometimes. It doesn't really get it wrong per se. It just, if anything, my requests are too vague. But
Mm-hmm.
yeah, it's just, and then my job is come down to just reviewing the changed files. Uh,
Except you blew the context window.
Twice. But luckily, there was a command in codecs called /compact, which compacted the conversation, and then I was able to say, please continue.
Oh, oh, that's very good.
It was. There is also an option in here. Let me show you. Showing is much easier than talking. This is my alias for codecs, by the way. This alias file that I made codecs right, I really like because it does this. When I cancel, it tells me how much RAM the process used at peak. Because if we're going to do one agent per codecs instance, we need to know that. So the most I've ever observed is 400 megs, and that was during like a kind of a big run, but I'm not sure why some types of workload, it seems unrelated to context window, some types of workload cause bigger RAM use. I'm not sure what.
Mm-hmm. Mm-hmm.
Anyway, what I was getting to was c.resume lets me see all the tasks. And then I can jump back in.
That's cool.
Yeah. And then I don't know what happened here. It must have conked out. Because this was on another computer, and then I left the area and walked off. So I guess I'll just let it go. So where are we at? Don't have the thing. Sorry. Don't have the thing, but basically how it works now is you come in, it creates you a new computer.
Mm-hmm.
It gives that computer the ability to make new machines, and then it stores all the file system stuff in this kind of a layout. So computers is just like the host's view of the systems that it looks after. C1, C2, C3 are the computer folders.
Mm-hmm.
And so basically, if you come in and you authenticate, I use your user ID to name your computer. And then if you have one, then I redirect you to it. But if you don't have one, then I create one and then redirect you to it.
Mm-hmm.
And then inside there's just a folder structure of agents, where each agent, A1, A2, A3, this is the working state of the agent, and I felt it necessary to add a parent link.
Mm-hmm.
So these are just IDs, so they're like guaranteed, because they're names within the one folder. Sorry, these agent names are guaranteed to be unique because they're just names within the agent folder, so you can't duplicate your names. But then parent is just sort of a symlink pointing to another agent ID.
Yeah, that makes sense. Yeah.
Children is just, again, symlinks to the agent IDs.
Mm-hmm.
Machine.json is just a symlink to something in this folder. Machines is, well, if once we get Cocoa, that'll be like the Cocoa container, but it's just these generic things which represent, I can explain this in a way I think you'll like. If this is the agent.toml,
Mm-hmm.
the container is this bit. So it's a container that was built with the Docker file, the environment that the agent needs.
Mm-hmm.
And then it has within it its running state, like which agent ID is it currently running, which might be 0 because it might just be on standby.
Mm-hmm.
And basically, when a request comes into the computer, it looks to see if the agent you want to talk to, because all you can ever do is talk to an agent, the agent you want to talk to, is it currently live and running on a machine? If not, grab a spare machine or create a new machine and then run the agent and then respond to the incoming request.
What's the difference between a machine and a computer?
A machine is one Docker image. A computer is the agentic computer in our language, and an agentic computer is a collection of agents, but each agent runs on a single machine. Machines is the fly.io name for them, but in our terms, that would be one Cocoa.
Right. Okay.
So that's how you consume the products of the CocoaNet. Is you're like, hey, I want a machine that booted off of this Docker image. The pool works away, and then you receive an attestation that, hey, here's this Cocoa. It booted off this image according to the AMD cert. Are you okay with it? And then when you're okay with it, you're like, okay, go. And you release the credentials that give you access to this folder, the contents of the agent. And then the machine begins to provision itself, ready to start doing the agent's work.
Right. Gotcha. So machine is effectively a provisioning of an agent inside of a computer.
Yeah. It's the underlying running thing. It's, in our, practically speaking, the way it is today, it's like one CPU, maybe like half a gig of RAM, some network access, whatever. So
Yeah.
very lightweight. And every time a new user comes to the site, it makes a new machine to run it. So they can be expensive if we get slash dotted or hit with a lot of traffic, but in the scheme of things, it's like, running a
Yeah.
couple of thousand is still within budget.
Yeah. All right.
Um, yep. And then agent.toml, that's the file I just showed you, the one that describes everything that the agent, the configuration of the agent.
It's my favorite file.
Yep.
I love that file.
Yep. The name is going to be the name of the agent as it, according to its parent. So it might not even, I might blank that actually, because
Why
that
not put
wouldn't,
that inside of Toml, the agent Toml?
because you might want many instances of it, but the name needs to be unique.
Okay. All right.
So I think what I'll do actually is I'll kill that, and I'll name it. The name will be in the parent, so the parent names it. So the child name, you'll get child name 1 and child name 2, but they'll point to the symlink of the agent ID.
Yeah. Yeah.
I should probably not call it an aid, because that would imply we're going to have aids by agent ID. Yeah, and so that means that you can't get your hierarchy conflicting, like you can't name them. You can't have the same name be the same child because you had to declare it like this.
Yeah. Yeah.
Home is a folder where the agent stores like its chats and its inner workings. So that would, in Codex, that would be like, so this is the home directory. In the typical home directory, you get .codex, and then this is where all the stuff to do. This is like the history, all the inputs, the sessions, the log, all the stuff that goes with the agent, goes with the codex running instance. But this wouldn't be the home as in the Linux home, because the Linux home can end up with a lot of stuff that we don't need. Like it can be used for cache directories and stuff. So if I go here, like I get the cache, that's like 263 meg. We don't need that. So it's not the home as in the Linux home. It's just the agent home, which is just like things that are special to the agent that you need to recreate it. Like it's message history, it's configuration data, the logs, whatever. Depends on what the agent does. It could be codex, it could be something else, it could be, just another process. Who knows? But that's the config directory where the agent gets to store some stuff. Workspace is the big folder. Like that's where all the Git repos go. That's where the agent works. Every time you start a new agent, that workspace gets reset to hold the repos and stuff that you need. And I think that the repos and things, like you kind of have to specify it sort of by modifying the agent toml, or I might need another file that was like the workspace config, because that would say like what repos you have access to. I'm not 100% sure. I was just going to wing it and then take a step back and see what makes sense. But somewhere in there you need to say, because the only way we have of storing files is Git repos. So workspace has to be, it can't be a Git repo itself. It needs to be a collection of 0 or more Git repos.
Yeah. Yeah.
And then in the computer, I wanted another folder that was repos. I think, like, I'm very open to be convinced that I don't need this, but it feels like each computer needs its own place to store repos, because it might need repos that only it has. Or it might be like if you clone something from GitHub, this is where it would go. And
Mm-hmm.
then your agents deal with this repo. And then periodically, one of them might ask for it to do a push, which would push the whole thing.
Yeah, yeah. I mean, that's your save point, really, isn't it? Um,
Yeah,
your workspace is mutable. Your buffer.
destructible. You can completely ruin it, and they should be independent or isolated from each other.
Yeah,
So like A1, A2, A3 can do anything they like in the workspace or anything they like within the machine, and it doesn't affect any of the other. Um,
yeah. But when you're ready to push, then reference repos, and that gets pushed out, and
mm,
others can then see what you've done.
yeah, I think that's how it goes. Or yeah, I think that's how it goes. But we'll see. If it's not this, it's something pretty close.
Mm-hmm.
And then yeah, machines was just the folder that I felt necessary to have because you need to track what the actual hardware is doing.
Mm-hmm.
So this is like the almost like the virtual machines. This is the database, and then this is the physical machines or the actual hardware that's running it. The
Yeah, you should very rarely need to dive into that, yourself.
you should
That's
never, but it would be readable so that you could understand what was happening.
yeah.
Um, yeah, but that seems to be the folder layout, and the big question is that enough to do everything?
Well, let me think through this. So what we were talking about previously is basically a buffer. You've got uh, your personal top level agent, which can have children, which you've got there. It's a link to child agents by agent ID. That does each child have a similar folder structure? Spawner.
Yeah, every
So
child looks exactly the same. It's just
yeah,
the exact data is different, but those are
yep.
the things that it must have.
So I go ahead and I'm talking to one thing. That one agent can spit up an arbitrary number of children. Each children has the same structure. Agent Tommel says what the agent is for. I can go in and mess with that Tommel um, to get it to do specific stuff. It's got its buffer. It knows where to store it, and it knows where what it's running on. Does it need anything else? No, I don't think so. Um, I
The
mean,
trick is,
ports and
sorry,
so on.
ports
Well, not ports, but interaction between the parent agent and its children.
or the children and the
Are
children.
yeah.
It could be done using DNS, so using the names. It could be done using TCP connections directly between them,
Yeah.
or my preferred way that isn't. I'm not sure it's. I don't think it saves us any time now, so I'm not contemplating doing it. But there'd be a folder called messages, and then in there would be an inbox, and then you would have like um, C2 agent 1 or agent 2 slash, and then like all your messages, like
Mm-hmm.
message 0.json,
Mm-hmm.
message
Not sure that's
1.json.
not sure that's necessary.
What? Why not?
Well, you've got a parent can talk directly to its child.
Yeah, but the thing is, it like how is the question, right? And so talking through the file system is a blockchainable way to do it, because otherwise, when you communicate using any other method and you don't snapshot it down, you can't recover the comms that were going on. You don't know what happened. So in order to, this was chain joining. This
Is,
folder is chain joining.
isn't that part of the work of home?
Uh, you are not wrong, but messaging feels very special, and home was meant to be more about long-term storage rather than high-frequency
Okay.
chatter. You're not wrong, but you could argue that you could put children in home. As well. The reason for home was it just sort of every app that we use, because we don't want to be the ones writing all the apps, like Codex, for example, they always have like a little config area or a little place where they need to store some files that aren't part of the work they're doing, but you need to set them up there so that the program runs.
Yeah, I see.
That's sort of, it's another name I was going to call it was config, but then the fact that it also stores the chat history there, chat history is not
Yeah,
config.
it's not config, is it?
No.
Um,
But I mean, the environment variable that Codex uses is they call it Codex home. So I just called it home, like general home.
yeah, okay. All right, so that's basically where stuff gets stashed
Yeah.
that the
Messages.
system needs.
Yeah, messages. I was just going to shortcut that and just use TCP/IP because we're not really in the realm of blockchains yet. But once it comes time, the messaging will be done on the file system, which means that it can be captured. Because I just want to point out that the computer, this folder structure of the computer, is a Git repo. And so all of these changes, so the agents are working and running and doing stuff, they're firing up machines, they're shutting it down. Each time there's a batch of changes, we do a commit, so the computer is replayable. Because all these,
Right. We should
all,
also capture the messages.
yeah. But if you don't do messaging through the file system, you never capture the messages, and so what are you going to do, right? You can't replay, you can't repeat the computation.
Yeah, yeah. Okay.
Yeah. So to be blockchained, the messages need to be sent at a quiescence point, which is to say that you can be doing whatever you want in the workspace or with the agent or talking to the net or whatever. But when it comes time for messages, you need to quiesce so that you are recoverable at that point, because the message sending is the return point. Like we will snapshot you. You can't send a message without snapshotting. To snapshot is to send messages, and to send messages is to snapshot. Those two things are the same. It works the same for receive as well. Like to receive a message is to take a snapshot, and then the system quickly stuffs in the messages, and then a snapshot, and then now you've got new stuff.
Yeah, okay.
But that's chain joining right there, that bit.
Yeah, yeah.
Seems a lot easier to think about it as a folder, and then you just give access to, or you just pass the files around. You basically share the folder with each other.
Where's auth done in this?
I'm glad you asked. It's done in a completely separate application. So, auth is done. Oh, provision failed. Well, that's bloody hopeless, isn't it? Auth is done as a fly app that only does auth. So it's external to the system. I don't even know what to call them, because they're not agent machines, but they're kind of like the watchdogs or the process manager or the BIOS or the boot, like the there's some very fundamental lightweight Docker images that are running that make sure that all of this stuff is running correctly. So you never really interact with these machines directly. They just proxy things through to you or relay things through to you, but they make sure that the machines are on. They make sure that the system can shut down to 0. They check the auth and how they are configured to that they. So I treated auth as external to the computer, but you configure it to be an auth provider from wherever, and then when you accept that, however you configure the auth, that's what the computer accepts, but it's independent, it's pluggable. So like it could be a certificate or a signature. You could provide proof that you own a private key, and if the computer was configured to be bonded or bound to this public key or group of public keys, and you come in and you prove that you own that private key, then they'll let you in. But auth happens at the gateway, at that checkpoint, that front.
So the computer doesn't know who owns it or who has access to it.
No. In this model, the computer was named as who owned it. So if it was just using plain English, that one would be named Scott. And then, like, you prove that you're Scott to gain access to it. So I was, in effect, cheating by just saving on the amount of work I had to do. But what I could do is be like, I could have a little file that was config.json that could have more advanced configuration that was relevant to the computer. But it all comes down to what process is interpreting that file. So right now the auth just interprets the computer name, and that's all it uses to decide whether the auth is valid or not.
Doesn't that? So we want to be able to move this object around, this VM.
The computer, C1.
Yeah.
Yep.
Yeah.
Yep.
And doesn't it need to know who has rights to it to move? When it moves saying, okay, someone's knocking at the door. I recognize you. I'll let you in. As opposed to an external thing saying, yeah, I recognize you. Here's the computer. Crack on.
Well, in this model, the computer knows what its name is, and in this very simplified auth model, that's enough to know, because when you try to come in, you have to present your validated user ID based on the external auth provider. And if you provide that, and it checks with the auth provider, and it matches the computer name, then it lets you in. So you are right in that that is a concern that must be dealt with. I've just taken a shortcut here by leaning on the name of the computer, which would be effectively the same as putting a line in config.json that said allowed user ID, blah, blah, blah.
Right. Yeah.
I would imagine that we will eventually move to using Linux access models. So we'd just have honestly, etc/password. And then that's it. You're like, these are the, I don't see why we should confound ourselves with reinventing access control if we just,
Yeah, I agree. I'm just thinking about the pattern here. So if I had a VM,
yeah,
and I could SSH in with a cert, and you could also SSH in with a cert. The validation is inside of the VM. It's the VM that decides whether to let you in. And so if you move that VM data center to data center, it's like, and then I'm going to SSH in to it because I know it's new IP, then it still knows that your cert is good to go.
Can you say that one more time, please?
So in the VM model, I set up a VM.
Yep.
I get SSH cert access. You get
Mm-hmm.
SSH cert access, and then we move that VM to a completely different machine.
Right.
We know the
Yep.
location of it.
We could totally do that. It will depend on just so. I'm pretty sure that in Linux that's called PAM, which is like the pluggable access module thing. So if I go to this folder, somewhere in here, yeah, somewhere in that, like, how we choose to implement so pluggable auth is in Linux. It should be something like that we copy and just store the file of here. But the point I'm trying to make is that it always depends on who's running it. So the runner of the computer needs to be configured to look inside, because this is not a running process. This is a static collection of files. And so something needs to have the ability to read inside the computer or a piece of the computer to know what auth it's going to accept.
I see what you're
So
saying.
it's not a live running process that you can query. Someone needs to read the files and then interpret what you're going to do with it. You know, like if I totally took over the host, I could read inside that and just let anyone in. Or if I was an honorable host running under Coco rules, I might look inside the config and decide that a particular Ethereum wallet was valid or not, and then I'd let it do some stuff.
It's like a hypervisor function.
Yeah, the hypervisor, that's the thing. The hypervisor gates who comes in, and that's why that Coco model needs a top level chain that makes that decision for all the computers that are hibernating or that are just on disk.
Yeah,
That
it's a
top level,
static. It's just like
yeah,
an image
it's
that you
static,
spun
yeah,
down.
and so that you need a highly trusted Coco constrained top level chain that sees a request come in, and then it's like, okay, I'm going to read the static files that only I can read, and I'm going to check if this request is valid. Is it valid? Yes. Okay. Now I'm going to fire up a machine or a Coco container to run or process this request. Okay, the container's up. I'm going to check the attestation report to make sure it matches the required Docker file and the other security concerns. Yes. Okay, I'm going to release the access keys inside of this Coco, and now it can read this slice, the A1 slice of the file system, and then off it goes.
Right. So that hypervisor could reach in and saying, "I've just got a request to spin up this computer with this agent, and let's, what's your side of the key? That's all I can see. So I'll do the auth for you. Thank you very much. If I'm happy that works,
Yeah. That seemed to be the lesson from how Coco needs to work, is that there has to be a trusted space that's running, so a live process that is trusted to have never ever leaked its keys or anything like that, and that's the thing that decides if a request is valid and if it's going to spin up a container to process the request.
That's right. That's right. And I think I do think having that config.json, which is here's the acceptable people can run me,
Yep.
is available, but the hypervisor still needs to reach in that because that's just at rest.
Yeah, it could be stored externally, but it
Oh,
sort of
no, that,
amounts to the same. It's like, well, the
no.
hypervisor has to see that. Now, it could be published, so you could
Ooh, I don't like
like
that as much.
it could be
Um,
public keys, but it really is better as I I guess I didn't see, certainly not at this stage. I didn't see the point in fretting over it too badly, whether it's inside or it's detached and outside or whatever.
well, I think you're right there, because there seems to be a ball of string to untangle there.
Yeah,
But I think ultimately, um, I was very taken on our last conversation when you were talking about computer being an object.
yep,
And being an object, it should be able to say or answer questions, even at rest. So this hypervisor reaches in, can only read config.json
mm,
and say, okay, this guy wants to run you. Are you
yeah,
all right with that?
yeah,
Even though it's not running, you know what I mean? It's
yeah,
just
yeah, yeah,
reading the thing. It's
yeah,
like, is this on one of your authorized people? Yep, it
yeah.
is. Okay, now you got running instance.
That's right, that's right. Something needs to do that, and that something needs to stay on.
Yeah,
That's why we need it.
I don't like having all that external, because of
Nah,
the
yeah, I like it.
portability.
I like it internal. I like it as a unit. Um,
Because then you could actually get multiple trusted auth gateways.
hmm. Well, another way to do it is you could supply these like default default agents that you specify and they run. So a request comes in, the big chain looks at the request, looks at the encrypted computer, but it knows how to boot one Coco, the auth Coco,
Mm-hmm.
and then that Coco runs, and that Coco does the decision here, whether it's gonna let you in, whether it's gonna let the request in or not. So it would be like turning on a very tiny part of the computer, almost like Wake on LAN, where it's just booting enough of the computer to process the request, like, is this a request or not? Um, but
Yeah,
yeah, the top level chain ultimately is always going to have the keys to unlock the computer anyway. So it's sort of like, I'm like, why not just read the data and make the decision in the top level chain rather than having to fire up a Coco, pass the keys around, decide,
yeah, no,
like
fair point. I think I'll
it's,
do for now.
yeah, the top
Because
level chain always has the keys. Otherwise, it's like you can't get around that. That's why we need a blockchain to be there. That thing that's always on and is trusted by all.
yeah, yeah, okay,
Because if we expect people to make that themselves and maintain that themselves, then first of all, you burden everyone with this base cost where they got to keep a Coco running all the time. Otherwise, what's going to, like, it needs a pilot light to be able to
mm-hmm.
light the bigger thing. Otherwise, you got nowhere to source your energy from, your execution energy. Um, and also things like key, measuring the attestation, releasing the key conditionally. Like, those are bits that you shouldn't really do yourself. They should be done by a certified, highly qualified central party that was audited, and then you all just lean on it. And then I think that's the bit that's holding back Coco from mainstream, because if you provide this like irrefutable global key management service that only releases the keys to your computer once the Coco has booted and been attested, and if the request coming in is authorized, you take away like the two biggest problems of running things in a Coco. You just become a hoster and no one gives a shit.
Yeah, I think it was about 3 calls ago. You're talking about that key management piece being part of the service.
It's the critical part. That's what that, and I love that because it gives us a reason to be a blockchain. It's a reason to be at this top level. It's a reason to have an internal currency because you got to pay that top level chain, and that top level chain has to pay for the cocos that you're going to consume. And so that's the top level chain is the market manager. It fills the orders, it checks that the market is orderly and secure.
Mm.
But that's why you need a currency in there because you need to trade cocos from all around the world based on different details and properties. But this top level thing has to be there, and it has to be able to call on cocos that people have permissionlessly entered into the pool for service. It's got a
Mm-hmm.
reason to exist, like a strong reason. Without it, if you want a cocoa alone, you're going to end up in the situation you have right now, which is cocoa is a pain. Not many people use it. It's you need a key management service somewhere, so you're either going to use an Amazon key management service or run your own, like with some fucking $2,000 bits of hardware that now have to be redundant and spread around like it
Mm-hmm.
rapidly falls apart on you.
Mm-hmm. It becomes too much of an arse if you're just trying to, fucking get some
If
loading
all you
costs.
want to do is fire up an agent, a chatbot, then Coco becomes insurmountably hard. But in our
Okay.
system, it should just be trivial. Like you just like as you vibe code with the agents, they just deploy the computers and the agents just deploy into this Coco environment. And you're like, oh, is it fully confidential? And you're like, apparently.
Right. Right. Yeah.
And you're like,
And
oh, it's
so,
always at market rate. Yes, always market
yeah.
rate.
And so key management there needs to be at least one, but there can be more than one, right?
Well, you need more than one because you need crash. You need crash and net split survival.
Yeah.
Like it gets super interesting when you deal with consensus running Cocos. So you definitely need consensus because like Cocos can't be replayed and they can't be it, but you still need consensus because you might crash and you need crash fault tolerance, which is 2f plus 1. So 2 times however many computer failures you want to tolerate, you need 2 times that plus 1 to break the tie,
Yeah.
which is better than 3f plus 1, which is what you need to break Byzantine.
Yeah. Yeah.
But, like our key management service, would run it in every setting on earth basically, and it just sort of figures out
Yeah.
how to
But to
balance
to
itself. And
to at the start, we can deal with lack of fault tolerance, and we can deal with that at a more traditional level, the server level. Um, but ideally, it would be on a blockchain computer.
yeah, that's right. And
Mhm.
if we do it right, it sort of allows you to split off pieces of the top level chain to go dark with. Like, so you're running on this top level chain and you're like, okay, we're preparing to net split, or we were involuntarily net split, but the key management system can still continue. Even though you've been cut off, it's like, oh, there's only one of me now. Okay, cool. Well, let's just keep going.
Yeah. Yeah.
um, which I think is great fun. And then I really do think that using Coco, we can actually supply the ultimate in edge computing because you can start putting Cocos like in the same street as the person that was requesting it. Like you can't get better latency than just down. It's connected to the same fiber box. It's connected to the same. You can just be as close as you can be so much closer than an actual data center, and the latency and the the fees of data egress and moving it around will just be so much better.
Yeah, and you could actually just host yourself on-prem if you want.
Yeah, if you want, right? So
Yeah. Okay. All right.
it's a
That works.
powerful model, but if we can just look, I don't know that we'll call this layout version 1, but the essence is that we can model the whole thing as a big file system.
That is the beautiful part of it. That is really beautiful. The movable computer object, like a
Yeah,
VM,
yeah,
is fantastic.
yeah,
It's like, and because it's at rest, it's trivial to move.
yeah.
Um,
It's a repo, so its integrity is assured.
yep, yep. For us to move it, how do I find? What's the equivalent of DNS here?
So I haven't done this bit, but I was just going to have a mapping between computer IDs and computer names. And so long as the name wasn't already taken, you can call it anything you want.
Okay, and would that be on chain again? Ultimately?
Ultimately, everything would be on chain, yeah, because first of all, there's like the first come, first serve DNS. Second of all, there's like pay some money to get sort of more privileged DNS. But ultimately, we want to get to just my friend said so DNS, which means that you can have multiple computers named Bob. It's just everyone in a particular group knows what I mean when I say the Bob computer.
Mm-hmm.
And so we can avoid this whole stupid global namespace problem that's sort of plagued the internet since the beginning.
Right, right. Like local IPs, yeah.
Yeah, so it really is not. They start as IDs because you need that to give them like assurances. Like the computer needs a Genesis block that holds a public key in it to say who can sign who can produce the next commit. To
Mm-hmm.
be self-contained like that, it needs that ability. But how you map the names externally is entirely in the eye of the beholder. And so, I'm providing a very basic, crusty form of DNS just to make it easier on the eye. But you can, it's whatever you subscribe to, so long as it unmaps it to this hash of a Genesis block of a computer, you'll know where to find it.
Right, right. Okay, that works.
Yeah, the bigger problem is going to be like taking debates like or discussions like we just had and putting them into agents with a knowledge base so that the future changes can be more rapidly figured out, and all the paths explored and balanced and reasoned through. Because, I'm still winging this by hand. Yes, the bots are helping immensely for checking whether something works and all that, but it's still largely me driving it, and I'd like to get out from that problem.
That would be a matter of storing some context in a repo inside of an agent where the pros and cons, the discussions, the practical constraints are all understood and built on as discovered.
Yeah,
And then asking that agent, here is the structure. Is there a better way of doing this? And rollout would be quite interesting.
so is this structure enough to do everything?
It's a computer. It's a computer. You've got effectively in the agent the CPU in the workspace. You've got the RAM in the repo. You've got the SSD. in the messaging, you got networking. I don't see anything else needed. It's it's a universal computer, I think.
Why does it feel so small? Like it.
Well, because computers are small when you talk about them in boxes, like
Yeah, well, I guess the trick is that this folder can be infinite. Like
Yeah,
agents, you can have an unlimited number of eight. Like you can have like a million CPUs,
yeah,
and it's still a computer.
yeah,
So it's limited not by the tin, it's limited by the Cocoa network to supply you.
yeah.
Which
Which
I
we can, for all intents and purposes, call as infinite. I know it's not actually infinite,
yeah,
but
but it's
you
also
know,
like it's not like I hate that limit you hit when you're like, oh, this one server's not big enough, and then that change to go from one server to two or from two to three, it's like it does my head in. But this is just like, you know,
well,
this it
agents
does.
aren't bound to machines here, right? I mean,
No,
machines
they're
are.
they're only machines that form a pool, and then the agents that you want to run get loaded up into them.
Right, right.
So you could even have a throttling or a graceful degradation. Like if there were no machines available, you're paused, suspended. Like suspended is the default state as opposed to something you have to actively enter. And then when you get one machine, it would just work on the highest priority agent, and then it might shut down that agent and then run the next agent. Like you
Who spins
could
it? Yeah, sorry.
you could get away with just one machine running the whole thing, right? Like a sort of like a Turing machine.
And well, it is a Turing machine. I think that's what's unsettling about it. It seems like it's got all the pieces necessary to run an arbitrary load. Um,
An arbitrary load, right?
yeah,
Arbitrary size. It's good for small, it's good for big, and it's good for stop. Like
yeah,
stop is a very, very hard thing to do, right? Like it's not. It stops as part of its regular operation, so stopping's just natural.
yeah. How are machines spun up?
It depends on the infrastructure supplier. So in this case, we're using Fly.io, and so the computer
Mm-hmm.
has the little gateway processors. I haven't figured out what to call them yet, but they're like the BIOS processors or
Yeah,
the the heartbeat processors have keys to the infrastructure, and they can request for new machines to be created, or they can destroy machines, or they can suspend them, or turn them on, or reboot them.
right. And again, that is effectively infinite um, for all intents and purposes. And you can
But
spin
yeah,
up as many machines as you want. Uh, is there a binding between one agent and a machine, or
never,
is it?
never. It's purely the agents in their agent.toml do specify what the conditions of the machine that they're running on need to be. So
Mm-hmm,
in that file, they'll say like, I need a JavaScript environment, I need a Rust environment, I need something, something, something.
mm-hmm.
And so long as the machine fills it, the agent itself is the difference with the machine. The machine is just the running environment that the agent is deployed upon, keeping in mind that the agent specifies what executable files it needs to be installed to come with it as well.
So if the user gives an unfortunately large task,
Mm.
are new machines or how are new machines spun up in order to deal with that in a reasonable state, and where does
You mean
reasonable
like if
fit?
suddenly they ask for 1,000 new agents?
Yeah.
So the heartbeat processes that are running the computer recognize that requests have gone out in the file system here to make new machines,
Mm.
to make new agents, and then they look at the state of the file system here and the state of the machines here, and they balance it. So they'll be like, oh, we've got a request for 1,000 machines. We currently have a tuned scaling factor of a maximum of 10 per second. So we'll start our first 10, and then we'll assign the task to it, and then we'll see how quickly we're getting through the work. We may need to increase the scaling factor and turn on 10, 20 at a time or 30 at a time, but they'll have some complicated logic that lets them figure out the optimum rate, balancing all the constraints from which to turn machines on and off. Because if you get 1,000 agents, but all they're going to do is wake up and say hello world, you sort of wasted your resources if you fired up that many physical machines. So you sort of want to touch it a little bit and see the rate at which the work is processing, so that you can be a little bit economical about the way you do the machines.
What throttles it? See, if I went to be a real arse and I created an agent.
Your credit card throttles it ultimately.
Right. So if I create an agent that said create a copy of me, and create a create a child of me, and that's it. I did this as an undergrad and crashed Edinburgh Uni. Called it Rabbit. It was like all you do is you create another process, which creates another process, and exponentially it results in you going in front of the dean. That was an unfortunate.
Well, that's the difference.
But you're saying you ultimately
you're running out of money. Yeah, you're running out of money.
So you could, you could if you had,
if you had enough money, then if you're on Fly.io, for a time they wouldn't be able to satisfy you. But if you're on the CocoNet and you start paying, you'd cause the global price to rise. And so, because Fly is fixed, they don't have that natural.
Right, that's also. Yeah.
They can't naturally push back on you. But in CocoNet, it's like, well, the price just keeps going up with surge pricing until, and then the high price means people are like, oh shit, man, like join the network, get more machines, like people are paying.
Yeah. So you could do DDoS, but you just need to be a billionaire.
Yeah, but that's true all the time.
Yeah. Okay. All right. So
I don't know why there aren't more DDoSes from billionaires, but you never hear of a billionaire just doing something annoying with their billions, like buying all the cat food in the country and hoarding it. Like they never.
Sorry, but once one scroll of a 14-year-old thinking, "Oh, I'm going to mess with this," would run to ground pretty quickly. It would just peter out.
Yeah, you just run out of money. I mean, we'll take the money. Great. Yeah. So in Fly, we could probably, I don't know, maybe give you 10,000 machines within maybe half an hour. We could give you 10,000.
Yep. But then they're going to be clicking over quite quickly. And where's the user wallet then?
Yeah, that's a good question. Right now, it's tied to our wallet. Good question. Don't know. I think the computer would have a little bit of a wallet itself to allow it to do like self-running things. But it could also be done pay per request, so the user needs to pay for the computer to wake up.
So each instantiation of a running agent would be linked back to a wallet, or would it have
so it could
wallet?
Be. I think it could be the requester. Whoever made the request could pay for whatever work was tripped off, or the computer itself could have an internal wallet. Because in the case of a regular user, the regular user is represented by their computer, and so their wallet is in their computer, and it has some funds that are, I think, managed. Well, it has to be managed externally, which acts like the ledger.
Right. So when I instantiate my Agent Zero, then it has access to a wallet. It can give um, a kind of buying limit to each of
Mm,
the agents that I spin up.
mm. Yeah,
And
resource
those
management.
agents, yeah, those agents could spin up other agents,
Right.
but
Right, but
then keeping it.
that's real good though, because it means that you can um setting timeouts is the same as setting spend amounts. So you're
Yeah,
like,
yeah,
you
it's
get
identical. It's
half a
great.
cent, and it's like, okay, I'll see how far I get, and then it will naturally end from either time on the CPU, or too much calculation, or too many tokens, or whatever. But if you set money, then that's the same as setting a timeout.
That's actually quite a powerful way of doing it because
Yeah,
time is tokens. Tokens are money,
yeah,
and you set that, and at some point, you're going to max out your mum's credit card because
yeah,
you're a 14-year-old scrote and just playing around with it,
yeah, yeah.
and you just
But no,
spent two
I
grand.
I hadn't. Thanks for pointing that out. I hadn't really considered that, but I guess that would go in the config.json of the computer, which would
Yeah,
be your wallet address. The wallet balance would be stored outside. So in our initial run, there's the we have a computer, like we are the hosting computer. The hosting computer contains the ultimate keys to the infrastructure. It can, like, create computers or shut them down. But when you're in a computer, you can only create machines and shut them down. So you can only manage your own
right.
sphere. But our computer, I guess, would store in one of its repos, it would store the account balance ledger for the whole
Or
environment.
it would even it wouldn't need to have a transaction. It could just be a facility to go back up the chain to the original Agent Zero and saying, "Hey, you said I could spend $1,000.
Right.
I've run out." But if you don't spend $1,000, it's not actually called down, so there's no transaction. It's just a facility.
Yeah, like it maintains the balance, and then it knows that when you call on the infrastructure, it knows that someone's getting charged, and it just does the accounting.
Yeah, but the hierarchical thing back to, I call it Agent Zero. I know you got A1 there, but Agent Zero seems to be your entry point.
Yeah,
Your
those
entry point.
gateway things, right?
Yeah,
The heartbeat.
yeah, yeah. So that has, your cash in it, and then you can tell Agent One, you have a facility to spend up to and no more than $100 to do
Right,
this task.
right, right.
Uh, Agent Two, Three, similarly.
So all the
If
children. So to get your money, you got to go to your parent.
Right, but the important thing is there's no transaction unless that agent actually calls down on that facility.
That bit I don't get.
Um, so you can give Agent One from Agent Zero saying, right, I'm asking you to do this, and you've got no more than $100 to do it.
Right.
Crack on, and it finds that it does it in $10, and then it goes, right, okay, I'm going to call $10 back from Agent Zero, saying, I know you said I could spend up 100, but I only spent 10, and that's the point of transaction. So until an agent actually does work, it's not calling down any of the cash that it's been earmarked for.
Okay.
So there's no transaction costs. There's no overhead on. You don't need to transfer $100 to an agent because it might not spend $100. It might spend 10. In
Yep.
the same way as in a company, it's like, right, okay, your budget is 20 grand. It's like, oh, we've only spent 12, and that 12 is reconciled. But it goes up to accounts to get reconciled.
Yep. Yeah. So it's like an amount, and then you only have to deal with it locally.
Right. Yeah. Yeah. So there's no transaction fees until it's all. And you could even accumulate it between agents in order to keep transaction flow and cost low. All right, we're getting a bit into the weeds here, but I can see how that would work anyway.
Okay. Sounds good. Just give me 1 second, buddy.
Yeah, no worries. I've got another question.
Okay. Ask away.
Given data sovereignty is evidently a thing, um, where does an agent know it's running, or how can it be told to run only in this, country or on this
Oh,
machine?
right. That's down to the machines. So wherever the machines are configured, I guess further that would be a combination of config.json plus the it wouldn't be agent.toml. It would be like sort of like more almost like a config.json in here.
Yeah, it's like here's the available pools that.
Here's the allowable pools. This is what you're allowed to do.
Yeah, you can spin up any machines that you want so long as they're here.
Yeah. Yeah, something like that. I think that to set that agent by agent, it might. Part of me wants to make it a piece of the agent.toml that restricts that sort of along, but
It doesn't feel like it should be in there
because agent's more general, right?
Yeah, it's the work to be done, not where to do it.
The work to be done, not where to do it. Yeah.
But saying in, say, I don't know, config machines.json, saying, right, you can run, you have to run here in this pool. Your children can run here if you want, but we've got a preference to max out this pool first, and then if you need to go elsewhere, here are the allowable loads that you can place elsewhere. Because the reasoning is your parent is at the top, probably. Well, it's the greatest. Give me 2 seconds. If you have a sensitive task, then some of the subtasks may be unsensitive, so you can place them out.
Oh
wherever.
yeah. Oh yeah, you're absolutely right. But then, would it ever matter? Like, would you ever want to control that with more granularity than the computer level? Maybe, right? Because some
Maybe.
agents would do something special. But then now you're sort of saying that some of your agents do something much more special than other agents, which means that you need to be super careful that there's no bleed between them, which
Right.
is fair, but that also causes you to say, well, a child of a child of a child that's super restricted means that whatever agent gets access to the full agent tree, like if you can read this folder structure, then you need to also honor the most narrow restraint, and those restraints might be conflicting. So I'd argue that the only way you can really do it is at the computer level.
I see what you're saying. Because at the top level, you might be super constrained, but you
Yeah.
go all the way down to, simple arithmetic. Who cares where that's run? Um, but it's sending up and it's gaining sensitivity as it's going up.
Well, I was meaning the opposite. That maybe you've got some general agents that are sort of not super secret squirrel, and then deep down as a deep child, there's a super sensitive operation. But because the top level parent could look down and see that,
Mm-hmm.
and it
Mm-hmm.
might be running in an in a weaker location, that starts to break, and it gets
Mm-hmm.
quite complicated to contain it. Whereas if you just said, well, if that's your issue, then you need to run the whole computer with that constraint, then that's easy to manage.
Oh man, this is it's an interesting one, isn't it? Because
Yeah.
uh, if you spread out like a hierarchy of um, unclassified questions to agents to children, but the bringing those all together was confidential, and you wanted control over that. If you could see all the unconfidential ones, you could probably crawl back up to like network analysis. You're asking all these questions about this. We can draw conclusions from that.
Yeah,
I
so
don't.
it's
I don't
it's
know
sort
the
of
answer to
it
that.
doesn't really make sense. Like the computer, I feel like the computer needs to be the unit of computation, like the package of computation. It's like you can't
I think. I
everything.
think that's. I think that's the safest.
Yeah, everything within the computer can be constrained in terms of its sovereignty where it occurs, but it must all be the same.
You're gonna limit burst though there.
Well, I
I
mean,
can't see a way around it.
what are you limiting, right? Like if you're like this computer can only run on my infrastructure, it's like okay, well you've limited burst there, but if you relax that, like that restricting thing is a burst affecting thing. If you're open and you just go full cocoa, you get max burst.
Yeah.
If you restrict it in any way, and we sort of ask why, but you're welcome to. If you restrict it in any way, you're restricting burst.
Right. So at the computer level, you say, I want this to run in my. I want this
Yeah,
agent
but you
to
could
run.
maybe allow for price differences on a per agent basis because that's easy to do.
Yeah.
Whereas
Yeah.
confidentiality is hard because, sovereignty or other types of, what would you call those kinds of constraints? Like,
Uh.
that,
Yeah.
you
I don't
know,
know a group name, but sovereignty is good enough for now.
sovereignty
Yeah.
is good enough, right? So, sovereignty constraints are infectious, right?
Yeah.
But price constraints are not because price is a commodity. You're still allowing the switchability between. So you could set your sovereignty limits you could set per computer, but your price limits you could set per computer and per agent because you might have high priority, low priority tasks that you want, and it doesn't affect the sovereignty considerations.
Yeah. That's true. That's true.
I think the
Um.
word for it is species. You're asking for the species of the machine underneath to have some properties that you care about rather than just being like computer's a computer. You now care about where is it located? Did it burn carbon or did it burn coal? Does it,
Yeah.
you know,
Yeah. I guess what I'm adding is I you also care, along with price and carbon, you also care about where.
Do
Um,
you?
well, under cocoa, you shouldn't
Well,
necessarily need
yeah.
to.
You are still entitled to care about it, even with cocoa, because if North Korea turned up and became the world's biggest cocoa supplier, would you
Yeah,
be
and then switch it
suspicious?
all off. Yeah, well,
Well, not
they
just
could then.
switched it off, but you'd always be wondering. It's like, wonder what they did. Like,
Yeah,
what did they know? But there's also the the yeah. Sorry, I lost what I was gonna say.
yeah. So if I was North Korea, I built a huge cocoa farm, go
Cocoa
out to
farm.
the world.
Yeah.
Yeah, there's a perception saying, yeah, I'll could break cocoa. Sure, they could, but they'd have to make their own silicon. Um,
Or they may have found some vulnerability within the AMD chip, something like that. But what I was going to say was you could also specify latency, which is a reason to care about where. But
mhm.
if you care about where in terms of sovereignty, you need to set that computer wide. But if you only care about latency, then you can set it per agent. Latency and cost are definitely per agent
Yeah,
tunables,
yeah, absolutely.
but
Because some of these
sovereignty is
children
infectious.
maybe, yeah. For latency and cost, some of these tasks for the children might be just put it on the back burner. Come back
Yeah.
when you can. Um, Sovereignty is a real nut to crack. If we can crack that,
Well, I mean, we have. I mean, the fact that you can specify sovereignty at all is good.
that is true. But
It
by
has to
specifying
be.
a more narrow sovereignty, like computer
Nah,
level,
dude. It's got to be computer level because you can't. The agents. You can make conflicting sovereignty requirements. Like you can say this agent has to only run in France and this one has to only run in Germany. And then like, okay, where does the agent zero run?
well, here's an, let's do a walkthrough of a real example. Okay, so I'm running drones in Ukraine uh, as part of my agent A1. Um, Part of that needs weather reports. I don't care where the weather reports come from because weather reports are weather reports. But I care that the information about the drone strike is kept sovereign. How would that work? Would it
That's
all
just
have to
yeah,
be
but that's where
sovereign?
you're pulling the data in from. That's not saying anything about where your agents are running.
Um, so that'll be an external call.
But are you asking like you want one of your agents to process the weather data, and some other agents you want to process the more sensitive data?
Yeah, there are some. A parent might be doing something sensitive, but a child might not be. Um,
Right, but if it's okay, so if the rule is that children have to be operated within the sovereignty constraints of their parent, then I think it all works.
it does. It does
Which
absolutely. I'm
which
just.
kind of means that at the top level,
Yeah, yeah. That's kind of the most constrictive way of doing it, and it does absolutely work. What you're saying is, I can't burst out to North Korea for a child whose payload is, yeah, who cares? Don't care if anyone can intercept that.
yeah, you're restrained by what the parent. You can be more sovereign than the parent, but you can't be less sovereign than the parent, right?
Right. So you
So if the
inherit.
parent starts off as like, oh wait, no, that's wrong. You can't be. You have to be. Your sovereignty has to be a subset of the parent's sovereignty.
Yes, you can become more constrained, but you can't become more loose as you go
But
down the
then, but
hierarchy.
then that doesn't work because the parent can see the child.
Yeah, you're right. You're right. You're right.
So they kind of have to stay the same, right? Like it's
Um,
because the parent can see the child that's the problem. But you could have like two siblings, but that's the issue I was talking about. Like the parent, if one, if one child only ran in France and the other child only ran in Germany, where does the parent run? I think, look, the answer is not obvious if this is even possible. We at least know that you can do it on a computer level.
yeah, if you do it on the computer level as it stands now, then it constrains every child to the constraints of the parent,
Yeah, yeah, and
which which is maximally secure.
yeah,
Um,
you could make a world where the child could be less sovereign if the parent allowed that. Like if the parent gave its children some children that permission, but it could never. It's pointless to make the child more narrowly sovereign
well,
than the parent.
I think that is the rule, isn't it? So you could have a whole bunch of children who are simple calculators,
Yeah,
and the parent was doing something very interesting, which was meant to be sovereign.
yeah, but the parent has to give you permission to be less sovereign, and then that's okay.
Yeah, but you can't be more sovereign. So you inherit the sovereignty of the parent, and the parent can give you permission to be less sovereign, um, but not permission to be more sovereign.
Okay, all right.
I think that works. That's a bit of a mind bender.
Yeah, I know. Sovereignty is hard, dude, but
Yeah.
yeah. Okay.
But that would allow us a highly sovereign parent to give a whole bunch of child tasks that could be pushed out to a wider pool that I didn't have control over.
Yep.
Um, but that would
So,
need to be stated.
okay.
Yeah.
May we move on?
Yes.
Yes. Okay. Uh, this concludes what I think is the agentic computer structure.
Well, I've just tried to give it a hard kicking and stand fast to everything I've just said. Yeah, I agree.
All right. So I'll continue to make it. I am very annoyed that I haven't made it yet. The pace at which I was moving would suggest that I should have had it by now. I have most of it. So I got auth set up, so that authorizes correctly, and I set up the service and clerk and the
Oh,
DNS
you got
certs.
WhatsApp.
And,
Oh,
yeah,
awesome.
yeah.
Awesome.
You can sign in with like email, wallet, whatever, and then it was at some points making its own app, but then I, needed tuning, so whatever. Yeah. So what now?
So, what can I do with this right now?
Nothing. I'm sorry.
Okay. Uh,
What should you do with it though? Once you got it, that's probably the better.
well, I'm gonna try out on our Hopper stuff. Translate is probably going to be the first one because that is ideal for the parent-child structure. So it's a bit of an easy path. So translate once, then translate many times, get confidence levels from each, look at diffs, produce proposed at that
But
point.
what are we gonna do with it? It seems. First of all, how would you assure yourself that it worked? more generally than just picking an actual job? Like,
I'm
is
not
there?
sure about that. My plan at the moment is to just do a quick and dirty on one job and then see what
But
comes out
it
of it.
sort of feels like it's not a case of it's not going to work. It's like we can kind of see that it, like, how could it not work? Like, that's so simple that it.
Well, I would disagree with that. At the moment, it's going mostly through meat brains in order to figure out that this will work. But there's nothing like field trials.
There is nothing like field trials. I'm just bothered that we don't have what sound like good field trials to me. We have narrow trials, and I don't quite know what a good field trial is.
Hmm. Well, we've got a few to choose from. We've got the translation, we've got the business accountancy and fraud detection, we've got OSINT, um, uh, we've got threat analysis. Um, there are a few there. Now,
But they're
what,
all just point solutions, right? They're not
well,
the universal agent. They're not the
they're, they're,
concierge.
they're not the concierge, but without using it, you don't know what question to ask, I think.
Fuck.
If we was to choose one
Fuck.
from
This
there,
is
I would say
very
it's
annoying.
OSINT. OSINT is basically situational awareness. It seems to be a very wide space that you could apply for everywhere from banks to insurance to businesses to, whether you're about to fuck up with your wife. Um, the That seems to be a quite wide one. Is it a universally wide one? The concierge. Hmm,
The
yeah,
concierge is universal.
it is, but we don't know what questions to ask it yet.
Yeah, because the issue is you can get tainted by the kinds of questions that you want. Like the question you ask can alter the suitability. Like if your question is not free enough, then the answer is constrained by the question.
Yeah, absolutely. You start distorting it.
Yeah,
Um,
yeah. And you can end up wanting something like, I just wanted a better Excel spreadsheet, or I just wanted a faster horse and cart. But instead, I got this, what is this Model T thing?
right.
It, and you start chasing a problem that isn't even in the realm. It'd be like asking to, it's like, why can't the SpaceX Falcon 9 take me down to the local supermarket and back? Like, it's just, you're asking a question that it wasn't built for. When, there's a whole area of solutions that this thing could provide that are preposterous at the moment, like individual intelligence for every single person in the UK. You could probably do it for about 100 grand worth of tokens and storage. And you're
Hmm.
like, I have paused every single person.
Well, the other way to do it is, I guess, through provision or give the ability to provision a concierge for each person who wants to turn up and then look at what they're doing.
So launch the concierge. Well, where do we start working on ambient attribution?
Um,
Isn't that really the main thing that we should try and that's all
it
we care
is.
about, right? We're like, is this
It is.
thing, can we do ambient attribution on the system, and how the dickens would that work?
Ambient attribution is at the uh, BIOS level. Um, I would suggest a bit like DNS. So it's like, sure, there's a whole bunch of services needed for that. You need to be able to advertise stocks. You need to be able to um, look at
I don't think
the
you need to be able to. I
contributions.
don't think you need to advertise stocks to have ambient attribution.
Um, no, yeah, but it would certainly be helpful.
Stux seems like a separate but very useful service, which is
But
the
you need to
conglomeration of problems.
record contribution,
That
which this
is
does.
done. Yep, that's done here.
Um, and then on the attribution side, you need people to sign up and say, "Hey, yeah, I'll be beholden to the attribution bot, and I'll do this work, and here's my contribution." That contribution would be inside of an agent which is universally available to talk to.
Yeah, shit. Maybe what I'm asking is not possible for us to answer at the moment. I fret because I'm like, well, we got this thing that looks good, great. So did every other thing that we made. It looked great. This one I do feel special about because I'm like, it's so simple and so powerful that even if it's wrong, at least it'll be useful. Because I use
So,
it right now, so there's that.
yeah.
But then, you know, OpenAI and those guys, I mean, they're basically making fleets of CLI agents anyway. So that's not that special. Um,
So if I was to write attribution right now, I would spin up a computer, create the master agent. Uh, we've got contribution logging. The agent would need to be able to see into other repos about what people have done. And there would need to be probably a child that systematically or occasionally works out attribution. In order to do that, it would have to see how the usage was going, who's using what, how useful it's been, and then get the payment event sorted out. So you could do it inside of the computer. Is a question is how do you expose that to everyone who's using this? How do you make it available? Because you could do it inside of
does
a
it
computer.
become a computer? It's like the ambient attribution computer, just to use
Yeah,
this modeling, right?
yeah. You can see how you do it inside of this computer, but then what are you seeing? Everyone, this computer has access to everyone's repos.
No, like the ambient attribution agent does not need to be, it's clonable. So you can run it privately, like you can pull it in, run it within your inner circle, and it only sees what's in there and makes decisions based on it.
So if that was a computer and it was separate from a computer that did a thing, how would those two computers talk to each other?
Why do they need to?
Because at the very least, the ambient attribution computer would need to have access
Oh,
to
right.
your contributions.
Well, surely it would only be the repos that it needs to see. Like, why would it need to see?
Yeah, it could do. I mean, it'd be useful to
Because
see the chats and that sort of thing. But repos are, the actual work done, right?
yeah,
So you could argue that that's all that matters.
and
What
then
you've
the
committed.
identity in of the committer in each repo would be the identity of the computer that represented the person or the org or the something. Like the unit of identity is a computer, I think.
So if the attribution computer wanted to look inside of the repos of another computer which had agreed to use it as its
Yeah.
attribution agent.
Yep.
How's that done?
Just access. It's just sharing the repo. I think.
And so you just have access to that repo directly, and it's like every commit is your
Well,
contribution.
it's every commit is available, but when a payment comes in, I think the way it has to work is that the ambient attribution computer has to be the payment processor for the payment. So when you're about to get paid, it goes via that computer.
Yeah, yeah.
And which means
Uh,
that, we could set up a real big one, because if there was like one ambient attribution computer can be the public ambient attribution computer, which isn't to say you can't grab the image of the computer and run it locally or privately or alter it or whatever. But
uh-huh.
if we make this public one and we just finish saying that we think that the scale or the number of agents that the computer can run is unlimited, then that's enough processing power to process everyone's attributions, and all it falls upon us to do is to manage how we configure the agents within it to interact, to respond to requests from people where they ask, hey, can you attribute this payment against this repo, to take in arguments, to modify the knowledge base of what's fair and what works. And then, it would have one repo, which was the fairness repo, the fairness knowledge, where
Mm.
all the arguments that have been distilled down are stored, and that's what it uses to make its decisions. But at that point, I think we're looking at saying that the ambient attribution agent is really a computer, because internally it's made up of a collection of agents that do different jobs.
And has its own repos and has access to read other repos.
Yeah, whatever it's asked to read. And it can, critically, one of its functions is to process money, which is just something that one of its flavors of agents can do.
Right. Now, previously we were saying that money was at the hypervisor level.
Yeah. If you're in a public blockchain, then the public blockchain is the hypervisor.
So it would have access to not only getting money, but also spending money, as in, well, spending it for its own running, but also giving
Yeah,
it out to others.
well, the ambient attribution computer is a or service, because that's, God, it's kind of, agent is a confounding word, but this service, which is provided for you by a number of agents, is not it would be a great example of a pay to play service where you've got to, it won't do anything out of its own pocket. Like, it'll always run on zero balance.
Mm-hmm.
Anytime you ask it to do something where you can ask it to disperse this payment, it will always take a cut.
So how is that done in terms of this process? How is one computer going to ask for funds from another computer? So you've got a project and you've got lots of children in there. You've got multiple people coming into the same repo, and you're saying, right, can you work out what's fair here? Because we've just received some funds in, and we want to distribute those. What's the process?
The money goes to the ambient attribution service, and then it goes to the contributors.
So that
But it
money
takes a cut on the way through for operating cost, to actually run the calculation.
So, where in this config is that allowed?
That is a great question. It almost needs to be like a wallet.
It does, doesn't it? And
'Cause-
it needs to be able to send and receive funds.
It's almost like the ambient attribution computer, as one of its repos, holds the payments ledger of the whole blockchain. Because if it is the one that is going, if making a payment is updating some accounting within the ledger that it holds as a repo, then that's the surest way to guarantee that all payment is done using ambient attribution.
Yeah. And it needs some kind of payment gateway, of course. So it could receive, it could store who is owed what and who owes what.
Yeah, because it could, as part of its, in one of its repos, which it could hold private, it could store something like a Ethereum wallet private key. And so when it receives Ethereum, it knows that that's the keys that it uses to access that.
Yeah. Now it needs to hold escrow and it needs to hold incoming funds.
Whoa, what does it need to hold escrow for?
Well,
Can that be a separate computer?
yeah, no, it could be. It could be. But it does need to receive and send funds.
I think that it becomes the manager of the ledger, and that's how it sends funds.
What if there's more than one attribution agent?
What?
Well, say if you want to fork this.
Yeah. You could still chain them together. All I'm saying by if we make a public blockchain, it needs a ledger stored somewhere. If the only way to store data is in a repo, then who's going to control the repo? Surely only the ambient attribution agent is suited to do that, because you know that whenever the repo holding the account balances of everyone in the system change, it was done by way of ambient attribution. So every transaction was taxed in effect, and the balances went out to everyone around them.
Yeah. And so
That ties it in nicely, because otherwise that ledger, like I feel like we have to think in terms of repos are the only unit of data storage, because what else would it be in this system? All these other blockchains, they store it as a data structure within the chain itself, but we're saying that our chain is made of cocos, and the cocos are just pure execution environment that can do anything you like. But there's this other data structure, the repo, that can store arbitrarily any data that you want, as well as arbitrary versions. And so surely the ledger belongs in a repo rather than being a custom data structure.
I agree.
Now, it might be that there's a optimization on the data structure that's required for performance, but I really don't think so, because I think the key is to just have more repos. Like, you split the ledger into different domains or different use cases, and now suddenly your throughput is like massive again, because like you can always break a bottleneck.
Which leads to a computer having a wallet.
Well, the concept of a wallet is really just there's a ledger somewhere else that holds your records your balance. And the wallet is just the ability to assert to that ledger holder who you are and what you want to do next.
Yeah, that's true.
It doesn't actually hold the money.
Yeah, yeah. You're right. It's access to that ledger.
Yeah,
Saying
yeah, yeah.
the
You can
ability to
modify the
assert.
ledger. Yeah, that's all it
Yeah.
is. It's not actually, which is so stupid because it's not like, it's not like having a piece of gold. You don't hold anything. You just, it's just some external party.
Yeah, people are used to that though.
Yeah, the trouble is they think that it equates to gold, but whatever, different
Yeah,
can of worms. So all
yeah.
we're saying is that a computer having a wallet means that in the eyes of, in the first of all, there's like the running currency. Like the computer may need some currency to run it, and that's the currency that the hypervisor takes.
Yes, and that hypervisor holds whether it's on another chain or its own
Yeah,
chain.
yeah.
Doesn't really
Now
matter.
you could definitely have other balances in there, but
Hmm.
yeah, I think that the balance in the currency that the hypervisor will accept is what you need to be able to initiate your own actions. Otherwise, you're more than welcome to sit there and use a pace.
Yeah,
But that
yeah,
that ledger is maintained somewhere that the hypervisor accepts. And I feel like I'm proposing that it sits in one of the repos of the ambient attribution computer. Now, controversial.
hmm,
Instead of calling it the ambient attribution computer, which is dorky and annoying, we could bundle up a collection of functions to be inside one computer where it's called the Dreamcatcher computer. One of the functions is a collection of agents that can do ambient attribution. Another one is what does stux. Another one is
hmm.
what does debates for the ambient attribution. Like these key infrastructure pieces of the Dreamcatcher might be simpler presented as one computer because the repos that they interact with is common to all.
That makes sense.
Yeah. And so the canonical form, the canonical place where the um, attribution ledger is stored is in the Dreamcatcher computer.
Yeah. Would the attribution computer need to actually store any funds beyond paying for itself? Maybe it's
It would not need to store funds, but it would be the holder of the ledger of all funds within the
right.
system.
It's who owes what to whom.
Yeah, who owes what to whom. And it should not hold any funds because it should always have its calculations paid for by someone else because
Right.
that's the gas fee of the
Yeah.
system.
Yeah.
That's the you must pay the Dreamcatcher computer to cause it to tick. If you want a state change, your balance is going to change, and it needs to be triggered by someone who holds a balance or someone who's prepared to pay for you. So, if you come to a web page that's hosted on the Dreamcatcher, the infrastructure is gonna charge, even though the web page was free. The infrastructure is going to charge whoever agreed to provide that for free, whoever agreed to fund it.
Yeah. Now, inside of this structure, then, we're talking about inter-computer transfer of funds on a ledger. Where is the
So
config for that?
what? It would just be so the computer can prove who it is.
Mm-hmm.
We assume. Anyway, the computer can prove who it is, and the ledger holds, for example, the public key of each computer and its current balance. And then if a computer wants to send funds to someone else, it just signs a message saying send XYZ to ABC and awaits its processing.
Right. So the computer knows about the ledger.
The computer must the computer can know about the ledger. So it would be an agent in the computer that was capable of manipulating the ledger. But really, like, the config doesn't need to store the balance. The balance is stored on the ledger repo. And so an agent that knows about the ledger repo would know how to read it to figure out its balance and how to interact with it to send funds here, there, or wherever. And when you send it in the Dreamcatcher world, the gas cost is the ambient attribution fee.
Yeah.
So you alter the balance in any way between computers, and the gas cost is ambient attribution.
Yeah. Okay. However, the computer may not care to sign up to attribution at all.
Right, but then that means that it's not being run by our hypervisor. Like, the hypervisor is the collection of hardware that agrees to be governed by the Dreamcatcher computer.
Okay.
So you could pull yourself off that, but now you got to pay the infrastructure some other way, which could just be you put your own hardware in there and you're like, don't serve anyone but me. Okay.
Or we could run two, which is one is not attribution, and we just
Why would we?
cut.
Why would we do
that? Just to be a hoster.
Why not just be?
In that structure that you just suggested, there's no reason why someone couldn't use what's up on the screen right now to get a quite powerful system up. It would have a payment gateway of some sort.
Yeah.
And that payment gateway could be taxed in order to pay for, its own support. Or you could go into attribution world with everything that you just said in terms of there's a single ledger where who owes what to whom is stored, and that triggers payments from with the acquiescence of each computer, which all we're saying is, hey, I agree with this, goes to the payment gateway, pulls down extra money from credit cards or whatever in order to pay for whatever it is doing, including its own running. So there's two modes of operation possible.
Yeah, I know what you're saying. I'm just like, so we're proposing to bond the Cocoa pool with ambient attribution and other Dreamcatcher services that you don't have to use, but ambient attribution is related to them all because that's the incentive to conduct yourself in the Dreamcatcher way.
Yeah.
Okay, but I don't get why you're talking about an alternate system. Because
say if someone wanted to use all the loveliness of this, but didn't want to do attribution.
Right, so they would set up their own hoster. Why would you assume that ambient attribution was not monetarily competitive with not ambient attribution?
It should be, but it may not be to everyone's taste.
Taste? You mean like
Yeah, it's like, yeah, I'm a complete, bastard. So I don't want any of this
but
attribution nonsense.
yeah, but if you're a complete bastard, you're gonna want a lower price. So you're probably gonna go for the ambient attribution. Well, I mean, why are you bringing this up? Because you want us to set up that the fixed
Um,
price
no,
world, or
I'm just raising it because it's an option. Because right out of the box, um, we could set this up as a hosting environment in order to run work. Um, Attribution is
yeah,
part
that's the well. Hang on a
in
minute,
game.
though. Hang on a minute. I just while we've been sitting here talking, to think about the Dreamcatcher as a single computer suddenly makes it be that having all the things we wanted all at once might be easier than having some of the things incrementally. And I'll
Yeah,
tell you
that's true.
why. Because, like, we don't have to have functioning ambient attribution in order to run the ledger as a repo.
Yeah,
So we can start with the fixed price hosting because all it is the repo manager is just mechanical. It's just dumb. It just you want to send that much to here? Okay, cool. And here's a transaction fee of X whatever because that's what the cost of data and movement and whatever is. You want to run this agent on this sized on a 512 meg RAM
yeah,
virtual machine. Okay, the price is blah. And it just does mechanical, classical computing mathematics to maintain the ledger.
yeah,
I guess what I'm driving at is that it suddenly seems like the blockchain is not outside the computer. It's not this other piece that we have to build. The blockchain is the computer in the same way that the running silicon is outside of all the computers. It's just, you know, some of the silicon has keys to look at the state and it decides, oh, the shit, I got to do something, I got to do some work, do some work, do some work. Okay, go. And then that sends a message off to another static data structure, which some different piece of silicon is triggered by and goes, oh, that's me, fires it up, livens it up, runs it, run, halt. And then that's all that there is. There's no, like, if the ledger balance for, let's just call this thing that we're launching is just Dreamcatcher V0, I need to store a ledger because we
mm-hmm,
gotta charge people because I can't keep paying for it.
mm-hmm, mm-hmm,
And so we're the only data storage option we have is a repo. And so the
mm-hmm.
repo stores the balances. We can be pretty efficient with the data structures on disk, but that's by the by. Ultimately, there's a repo, changes over time, stores the ledger balances of all the people. When they pay in through the Stripe gateway, Stripe comes in, we recognize Stripe, we modify the balance. Now they have this much. When the infrastructure runs, it decrements the balance. Going from that to then putting agents in there that do ambient attribution each time the ledger updates.
You're right. It's just
What?
it's just an extra process, isn't it?
Yeah, it's just adding some
No
more
different,
agents.
no different from any other computer burning
No, but
tokens.
that's the thing. I'm like, what the fuck just happened? Like, where did the rest of the system go? Why
Mm-hmm.
can that do everything?
It can because it's got the basic components it needs. Um, it knows who has done what, and that's enough to run a classical host. Add in attribution onto that. It's just looking at distributing payments other than hosting costs.
Why did you say other than hosting costs?
Because attribution deals in distributing value from usage as well.
Oh, were you saying that uh could you say what you said again? I just like part of my brain like fell apart because I was like,
Yeah,
is that the whole blockchain right there, a computer?
yeah. So the record of who's done what and who owns what in terms, who owes whom how much. Um, that information can then be applied to attribution. But the additional point there is on usage, because the distribution event requires usage information in order to find out what the value is of a contribution.
Yes, you're absolutely right. You're absolutely right. So at the moment, the only consumption is going to be infrastructure costs and AI token costs.
Yeah,
And
yeah,
so figuring out the attribution there, we could just start it with a very simple calculation that just skims, 15% and just holds it aside and says we don't really we know what the hash of all the commits at each point in time was, but we don't really know how to attribute those funds, so we're just going to hold it in trust effectively.
yeah, yeah,
Okay, and then you've got like another repo that holds all the stacks.
yeah.
And then you've got another repo that holds all the pieces of hardware. So, like, if you fire up a new Epic CPU and you connect the hardware up to the already running system, there would be a repo that tracks like a host ID, a host public key, the fingerprint of the CPU. Like, it would hold a bunch of critical information about who that host was so that we can use it for maybe some reputation information in terms of how available that host was,
Mm-hmm.
how solid the connection was, where it was, latency, sovereignty. Has the owner signed up to something, like assured us that it's within a protected zone that we trust, all those different types of things. But
Mm-hmm.
really, when you go to allocate a job, those would just be advertisements in a repo, I guess. And it's like, I am
Mm-hmm.
this box, this is my capacity, I advertise this much capacity for this amount of price, for this price.
Yeah,
And then the takers of it are just like anyone who holds a balance in the money repo just says, yep, I'll pay that for that.
yep,
Hey,
yep.
am I fucking missing something?
No, no, I don't think you are. I don't think you are.
It feels like
Um,
lost a whole chunk of crap. Like, I always thought that that blockchain function, was a totally separate piece, separate from absolutely everything. But in actual fact, there's the Docker container that's capable of running an agent, and then there's the file structure that it has access to.
mm-hmm.
So if we make the NFS file system able to be backed by consensus based Git, and we make the computing be Cocoa, um, we have completed our job, I would say somewhat early, because, like, where else would you store the list of hardware offers other than in a repo? Right? It's got to be in a repo.
Same goes for solve stacks for DGIP.
Yeah, it's again got to be in a repo. Now it could be solved across held in multiple repos. That's fine. And
Mm-hmm.
then but where would you store the ledger of the currency of who owes who for what computing consumption and supply? Surely a repo. Like we just straight up don't have any other data structures to store it. And it sounds like those structures are sufficient because the Git data structure is actually incredibly performant. Um, Plus, you can scrunch it down and eject stuff from it and just
Mm-hmm.
casually rewrite history, so long as everyone agrees. And so you can keep the data structure small.
Yeah.
Um, and so because the chain itself isn't doing every single jolly transaction, like you fire up a Cocoa and you might run it for like 5 minutes or 30 minutes as it labored over a task. The load on the ledger or even the hardware tracking layer is significantly reduced because the unit of work is this agent as opposed to this classical function, which is what it used to be. It used to be like, a smart contract, you're trying to run this little function. So,
Mm.
that's difficult to bill for. But with an agent, it's like, no, you're going to run it for a long time. Like, you're probably going to spend, a few minutes at least on this thing.
Yeah.
So the transaction rate goes down because the transaction value goes up. Each transaction is worth a lot.
Right. Yeah, follows.
And then, the computation that one of them can do is huge. Like, you run one of these things full stop for 24 hours, it's going to do a lot of stuff. Plus, it's got all the AI token burn that, could be a separate ledger. It's like, this is the AI ledger and people can hold their own ones and whatever. Fuck. I can't believe that's it.
What were you missing?
It's the Dreamcatcher computer, and in it is the ambient attribution agent.
Where's usage data? People gaining value from things that others have done.
That would be, I assume, the at the end of each machine run would be like a usage report.
Yeah, that simple, wouldn't it? I ran this and I used this to do it.
Yeah. And it's like, and you only really store the output at the end. So if you want to recreate it because it was Cocoa and because some of the operations we used were repeatable, here's, you can rerun it rather than storing it all.
Yeah.
You rerun it, and so you can do things like sampling, where it's like, well, we had, 3 million invocations in the last week. Let's just fucking sample 1,000 and take the and just assume that indicates.
It seems very noble, doesn't it? I ran this. I used these salt stocks in order to do that,
Yeah.
and I I will pay you this
So the Cocoa
because
Complete, like the Cocoa Complete statement is like when, so before you start, you get the attestation that the Cocoa booted, and
Mhm.
that's when the chain decides, yeah, we're going to release the keys. But at the end, it gets like Cocoa done because that's how the hardware guy wants to get paid. But he also submits like, this is what was done, and
It's like
these
an
were
invoice. It's
an
like an invoice.
yeah,
Yeah. It's like
that's your
okay,
Cocoa bill.
yeah, right, and it's like okay, here it is, and
Yeah,
here's the result,
and you
and
can't argue with it because the Cocoa made it,
yeah, yeah,
and it doesn't have to say what you did. Like, we don't need to be the ones that ran it, and we don't need to see what you did. It just needs to say, like, well, we trust the environment that it ran in, and it did this, and so that's what happened.
and because it runs, so say someone generates a bunch of agents that does some work which they charge money for. If it runs on the environment, then that caches inside the gateway, and it's like, okay, and so 20% of that, whatever, is to be distributed. You can transfer the rest. And then ambient attribution kicks in and saying, okay, right, for that 20%, you get that, you get that, you get that for this run. Yeah. Seems to work. Don't know. I think we're missing something.
I think so too, but it would mean, if it were true, it means less work.
Yes. Yeah.
Like a lot less work. An infinite computer.
That is what we've got right there on the screen there. Infinite Turing device.
And then you have your own computer. It acts as a peer, but it communicates with the hardware through the ledger that this, call it a central computer, manages or brokers to give you access to resources in a timely and cost-effective manner.
Right.
And so then the work becomes, we need Cocoa ASAP, because that's like, we might as well have Cocoa. I mean, you could just do it as trusted stuff first, but Cocoa's the fucking business.
Yeah.
And it sets us apart from everyone else. Okay, so we'll get the computer model up and get the blockchain up using Fly.io, and we'll poke around at it and see how it feels.
Yeah. And
But
then,
that's a fully featured, except for the repeatability, the Cocoa-ness, and the consensus, that's a fully functioning blockchain mock-up. Like that's the front end, the consumable bit, the bit that you see and interact with. That's that bit done.
Yeah.
And then that means we can iron out all the kinks, and then we can bake down, okay, now we're going to back the file system by a consensus-based system, and then we're going to back the infrastructure using Cocoa and a key management service that always stays on.
Yeah.
Oh, man.
And then we start to build out a dumb attribution to start with, but it's got all the pieces there.
Yeah, it's got all the bits, eh? Even a trivial agent that just has a fucking guess would show the point, I think.
Yeah.
We'll get the point across.
Yeah.
All right. Oh, well, man, that's chilling, actually.
Yeah. Right, I'm going to need to go.
All right, sweet. I'll see you. I'll stop the recording.
Yeah.